This video is about the acidity of a substance and how we actually measure it. The acidity is measured by measuring the concentration of the hydrogen ions that are in the solution. Before we actually get into the actual measurements, we should also look at water. Water has the ability to self-ionize, only to a very small extent. So if we have two water molecules, what tends to happen is that one hydrogen ion moves from one water molecule to another, giving us an H3O plus and an OH minus. We can represent this in an equation as written on the screen. That reaction only occurs to a very small extent, and when I say a small extent, I mean 1 in every 10 million water molecules will do this. However, this is a very significant reaction in terms of solution chemistry. Since water can self-ionize like this, we can actually measure the concentration of these hydroxide ions and the hydronium ions, and they have been measured to be at 10 to the minus 7 molar in a pure water solution. Now, obviously, because water is a neutral substance, the concentration of the H3O plus and the OH minus is going to be equal. You notice we're now referring to concentration using the square brackets. So down the bottom you see it's written as H3O plus is equal to the OH minus concentration in a neutral solution. This therefore means that the pH is going to be 7 in a neutral solution. We've already talked about this in junior levels. And in an acidic solution, we're going to have more hydronium ions in solution than we are hydroxide, so the pH is going to be less than 7. And in a basic solution, we'll have more hydroxide ions than hydronium ions, and our pH will be greater than 7. We already mentioned that the concentration of the hydronium ion is equal to 10 to the minus 7 in a neutral solution. This means that if we take the multiplication or the product of the hydronium ion with the hydroxide ion, and both of them are 10 to the minus 7, if we multiply them together, we get 10 to the minus 14. And this happens in any solution, as long as we keep the temperature at 25 degrees. So if we increase the amount of hydronium ion, or the H3O plus ion, then the concentration of the OH minus will necessarily decrease, so that that product of hydronium versus hydroxide of 10 to the minus 14 always is the same. We call this relationship the ionic product. Multiplying the hydroxide by the hydronium ion will always give us 10 to the minus 14, no matter what solution we're in. We can use the ionic product to help us calculate the hydronium ion concentration and the hydroxide concentration in a solution. So in this case, if we take 0.1 mole of hydrochloric acid and we put it in to make a litre of solution, we should be able to calculate the H3O plus and the OH minus. Since we know that hydrochloric acid is a strong monoprotic acid, it's going to completely ionize in solution and give us 0.1 of a mole of the H3O plus. Since that's resting in 1 litre of solution, the concentration of the H3O plus will just be 0.1 moles per litre, or 0.1 molar. Now that we know that the H3O plus concentration is 0.1 molar, we can use the ionic product to calculate the hydroxide concentration. We know that the hydronium ion concentration times the hydroxide is always going to be equal to 10 to the minus 14. We also now know that the H3O plus concentration is 0.1 molar, so therefore we can calculate that the hydroxide ion concentration is just going to be equal to 10 to the minus 13. So it's just 10 to the minus 14 divided by 0.1. I cannot stress strongly enough, you need to write out these things each time. H3O plus times OH minus. If you just put figures down without putting what they refer to, you're going to get yourselves very confused, as some of these problems become a lot more complex later on. Let's have a look at another example. In this case, we've got nitric acid, which is a strong monoprotic acid. So the concentration of H3O plus in that solution is going to be 5.6 by 10 to the minus 6 molar. We can use our ionic product to tell us that H3O plus times OH minus is equal to 10 to the minus 14. Therefore, if we want to solve for the hydroxide concentration, we just need to divide 10 to the minus 14 by our H3O plus. So substituting in our figures and doing our division, we come up with an answer of 1.79 by 10 to the minus 9. Of course, you guys need to be able to manipulate these figures with your calculators, and that's something that I hope you've learnt in maths rather than in chemistry. just a couple of questions to think about. Why are we only using monoprotic acids in these particular equations? I think if you think about it, you will understand that we're talking about the hydrogen ion concentration. So in this case, we can equate the hydrogen ion concentration with the concentration of the acid itself. If we used sulfuric acid instead of nitric acid, we'd have 2 protons to donate, and so therefore our hydrogen ion concentration would be twice as great as it is from the nitric acid case.